My dear JEE 2027 and 2026 warriors, welcome to the next class of your units and dimensions. And previously, we have seen what is unit, what is a physical quantity, what are the fundamental quantities, what are the derived quantities which depend on those basic quantities, right? And then after units, we saw what is dimension and how to calculate the dimension if you know the formula of such physical quantities like force, work, power, pressure, acceleration, speed. You know now how to do that. In case you have not seen that particular class, please check it out right on our channel, Vedantu JEE English, the #1 JEE English channel in the country, my dear students. So go down and you will see this particular class of units and dimensions. And like in every class, I give you homework, and many of you have solved the homework. Really proud of you, my dear students. Very good, Sulochana. To God, very good, Sumit, BTS lover, Jafita, Aliza, Vanaja, Sadhana, and Kulu. Kulu, I was really touched by your message. Sir, I'm from a small village in Andhra. I'm studying 11th. I don't take any coaching due to family reasons. And his father died when he was 4 years old. That's really sad to hear. And my teaching is awesome. And I like your smooth explanation. Thank you, sir, for giving this content. Really, this content made my day. You not only deserve like and love, I mean, a lot of support. Thank you, Kulu, and we'll support you in every possible way. And I'm pretty sure in 1 2 years, whenever you write your J exam, now you will be doing extremely well. You will make your mother proud and your entire village and town also very proud. Okay, I'll be waiting for that day. And hats off to you. And stay strong. We as a team at Vedantu are with you. Okay, your captain is with you. Thank you so much for that message. Okay, so let's begin with the class. And if you've not yet smashed the like button, please like it right away, right now. And a big kudos to all our rank holders. We bagged All India Rank 1 in the ISI exam, which is an exam which very few people might know about, but those few people give it with full competition. It's the toughest examination, even after JEE Advanced, it comes above it. And Rishit got All India Rank 1, complete long-term student at Vedantu. Last year also, ISI exam rank 1 holder was from Vedantu. So it's a very big thing. It's not an easy thing. And also rank 15 Karnataka state topper, yes, Daksh, who got even 120 out of 120 in mathematics. So, there are so many stories you might not have heard about, and so many toppers whose stories need to be heard and needs to be celebrated. So, my dear warriors, this Saturday, stay tuned, because 6 o'clock there is going to be a grand celebration. All teachers from all the channels are coming down, and there is a big meet with all the parents and the students and the teachers and the team. We are all going to be in the Vedantu Achievers League. So make sure you are also there. Join us online Saturday, 21st of June. All right? Great. So now let's talk about the different applications of dimensions. Let's talk about the different applications. Hi Hima, hi Vasuki, Moonlix, Pavitra, welcome TN, Nobody, Introvert, welcome Abhijit, Amira, Tharuna, Cupcake, Red, Silent, welcome aboard guys. Yeah, good evening Sumit, good evening. So I'll give you all the different applications one by one. First is, okay, I think. Yeah, I have the page. Okay. First is basically dimensional consistency. Dimensional consistency. So we saw what dimensions are and what are those basic dimensions: mass, length, time, ampere for current, and then you have K for temperature, mole for amount, candela, CD for luminous intensity. There are two auxiliary units. The angle and the solid angle do not have any dimensions, but they do have units of radian and steradian. Please mind it. You can have something without dimensions, but an unit. Okay, it's possible. So you have seen that. So what is the meaning of dimensional consistency? It means if you put some equal to symbol, and if you put something over here, some quantity over here, okay, and some other quantity over here, then the dimensions on the left hand side and the right hand side should be equal. So if m's power is x, l's power is y, times power is z, here also m's power should be x, l's power should be y, times power should be z. It can't be anything else. Also, whenever we add and subtract things, you can only do so for similar dimensions. Meaning, if m is raised to x, l is raised to y, time is raised to z, here also m should be raised to l, m should be raised to x, length should be raised to y, time should be raised to z. Only then this is allowed. Otherwise, it is said to be dimensionally inconsistent equation. So the first rule says that the dimensions of the physical quantities on both sides must be same. Also, the second rule is only physical quantities of same dimensions can be added or subtracted can be added or subtracted. And when that happens, when these two conditions are met, then we say such equations, whatever they are, such equations are said to be dimensionally consistent. Dimensionally consistent equations. Such equations are called as dimensionally consistent equations because imagine, example of these rules would be, imagine on the left hand side you have force and on the right hand side you have mass. Is force equal to mass? 100% it is not equal. So, if I put some equations, things will be very, very clear in your head. Okay. Say, I'll just put some examples for you. Yeah. Say, for example, force is equal to, 3 times of F1. Or let's say, F1 minus F2 is equal to another force. Both these equations are dimensionally consistent because here also force, maybe your force is 3 times another force. Here one force minus other force is another force. Even let's say another force F3 plus F4 minus F5 is equal to, let's say, F6. This is also dimensionally consistent. But what will not be consistent will be something like this. Let's say F1 minus mass plus acceleration is equal to velocity. It can't be true, guys. Everything has a different dimension. You cannot do that. Also, imagine something like this. Force is equal to mass. This is never ever going to be possible. So this is not dimensionally correct at all. So I hope you understood with these examples what do I mean by the dimension should match when I add and subtract, because I can't add newtons with meters or kgs with seconds. It is meaningless to do that. So kgs will be added with kgs, and on the LHS and RHS the dimension should match to maintain that equality. Now this is called as dimensionally consistent equations. But keep in mind, just because an equation is dimensionally consistent and it matches these criteria does not mean it is mathematically correct. Does not mean it is mathematically correct. So dimensionally consistent, but there is a big but over here, but can't guarantee, but can't guarantee but can guarantee whether it is actually correct. Can't guarantee whether it is actually physics wise or mathematics wise actually correct equation. But there is a catch over here. If an equation, if an equation is not correct dimensionally, is not correct dimensionally, then it must be, then it must be factually incorrect. It must be factually incorrect. So this is a very, very interesting criteria. So if dimensions are matching, does not mean actually it makes sense. it's fine. Okay, it's just like a satisfactory condition, but it is not necessary that it will always be true. But if it is not dimensionally matching, then it can't be factually any kind of formula. Let me give you an example of this. Okay, things will be very, very clear. Just imagine I give you an example of, you know, distance is speed into time. Speed into time. Let's say I write distance is 5 times of speed into time. If you ask me dimension wise, are they matching on both sides? The answer will be 100% yes. Because if you see the dimensions over here are of length, speed has a dimension of length and time raised to -1. Time over here has a dimension of t raised to 1. So technically, t raised to -1 and t will cancel, L raised to 1, L raised to 1. So dimensionally, 100% they are matching. So it is definitely dimensionally correct. Dimensionally, it is definitely correct. Dimensionally, it is consistent. But if you ask me factually, fact-wise, just think about it. This does not make sense. Distance is never 5 times speed into time. Distance is speed into time. So factually, this is basically factually correct. But factually, this is definitely wrong. Factually, definitely, this is 100% wrong. Fact-wise, physics-wise, mathematics-wise, whatever, chemistry-wise. Is this absolutely clear, my dear students? Similarly, hi, Maruthi. Hi, Marut. Hi, Kasturi. Good evening. But can we multiply in different? Yes, we can do that, Hema. Like I mentioned last lecture also, that you can definitely multiply and divide. There is no harm. Like we are doing over here, speed and time. I'm multiplying dimensions. I can divide dimensions. There is no harm in that. It follows simple rules of powers and mathematics. Okay, that is definitely allowed. Hi, Riddhi. Okay. Imagine an equation which is definitely wrong dimensionally. Like for example, this one. This is wrong dimensionally. So this is dimensionally incorrect. Dimensionally inconsistent. Inconsistent. So definitely it is definitely not correct factually. It is definitely not correct factually. Do you make complete sense out of it? This makes no sense dimension wise. So factually also it will not make any sense, because I can't subtract force with a mass, add with the acceleration to get speed. It doesn't make sense at all. Okay, so that is the first use to check whether our equations are dimensionally correct or wrong. And this is often used for eliminating options in an MCQ exam, not in JEE Advanced. JEE Advanced you will not be able to do it, because they are very smart. They will choose the options which are dimensionally correct. So just imagine in an exam you get something like this. Some blah 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 question is there. Okay, some big question is there. Big question is there. Some diagram is there, and in the end they are asking what is the displacement of that particle. Chumma, some big thing is there, and there are some options given, A, B, C, and D, and one of the options says, say for example, uh, speed square into time square. Another option says speed divided by time. Another option says speed into time, 5 times. And last option says, let's say this says 3 times. This is speed plus 3 times of time. Chumma, some random options are given. Obviously, out of these options, quickly you can analyze this and realize that displacement's dimension is nothing but the dimension of length. And out of this, it is very obvious that 5 times of UT's dimension, 5 is a number, so forget about it. Dimension of U into dimension of T. Dimension of speed is nothing but length by time, and this is just time, which comes out to be length. So basically they are matching with this dimension. Rest all will not match. So the only possible option which you can match is option C. Other options are dimensionally only wrong. Dimensionally only they are incorrect. So factually they can't be correct. So directly you can mark option C. So this method can be used to choose or eliminate options. So I will mention it over here. This is basically a trick. This is basically a trick to eliminate or basically choose options. Choose options. Okay. So this is how you do it. Everybody fine till this point? Give me a fire emoji or a thumbs up in the chat box really quick. Okay. Next application of your dimensions is as follows. Next application of your dimensions is as follows. It is basically used for dimensional conversion of units. Okay, so conversion of units, you can definitely use this particular method. How? I will tell you. If you know, if you know the dimensions of a physical quantity, then what am I telling? Then the units can be converted, from one system to other system. Let's say SI system to CGS, FPS to CGS, FPS to MKS, whatever system you can do that. Since the quantity remains the same, one can easily also say that number into unit will be number into other unit. So for example, 1 is that magnitude, unit is let's say kilometer, is equal to 1000 is that new number, the other unit is meter. Or something else, let's say you have there is a unit called as 1 Gauss, which is a magnetic field unit. 1 Gauss is 10 to the power minus 4 Tesla unit. You will learn that in 12th standard. Or let's say for example 1 gram, 1 gram is nothing but 10 to the power negative 3 kilogram, 10 to the power minus 3 kilogram. So N1 is the magnitude in the first system, U1 is the unit of that first system, N2 is the new magnitude in the new system, U2 is the new unit of that other system. So that's why I said N1 U1 is equal to N2 U2. And these are some of the examples of this. But how do we practically use it? Let me show you. How do we practically use it? Let me show it to you. Everyone, ready for it? Yeah, let's take a demo of that. Okay, I'm going to show you all the applications, guys, without missing anything. Okay, so let's take up an example. Say we take the example of force, and I want to convert between SI system and CGS system. In SI system, that is basically called as a Newton. In CGS system, it is called as a dyne. I want to find the conversion factor between the unit of force in SI units, MKS basically, and CGS, centimeter gram second unit. Okay. What is the first thing that we will need in order to do that? Like I said, if you know the dimensions of the quantity, then you can definitely convert. Okay. So the first things first, do I know the dimensions of force? Do I know the dimension of force? If you don't remember, no issue. Dimension of mass into dimension of acceleration. Dimension of mass is m raised to 1. Acceleration is basically L raised to 1 t raised to minus 2 meter per second square. Correct? Meters per second square. So it will basically be m raised to 1, L raised to 1, t raised to minus 2. So that is the dimension of force. Keep this in mind. Now let's start. I want to convert between Newton and dyne. So let's say we start with a Newton. Okay. 1 Newton. 1 Newton of force is, you take mass in that SI system, raise it to power 1. Okay. 1 Newton SI system is when you take mass in SI system, which is basically 1 kilogram, okay, raised to 1. So just 1 kg. Length is in SI system, it is 1 meter. So 1 meter raised to 1 only, because length power is also 1. Time in SI system is basically second. So 1 second whole raised to minus 2. So you need the dimensions for writing it in this form. Each fundamental quantity, write their units, fundamental units, okay, 1 kg, 1 meter, 1 second, and raise it to those powers whatever is needed or required as per the dimensions. Okay, now what to do? Now think, each, if you want to convert force from SI to CGS, convert each fundamental quantity from SI to CGS or whatever is required. Convert each fundamental quantity in their respective new dimensions. So think, what is the unit for mass in CGS unit? It is gram, and 1 kg is basically 1000 grams. 1 kg is basically 1000 grams. Is that right? So put, instead of 1 kg, put 1000 grams. I have converted kg into grams for now. Okay. A meter is SI. In CGS, it is centimeter. So a meter is basically 100 centimeter. Oh, so I've converted that also. But seconds, I don't have to do anything. So just leave it as it is. So it is 1 second and whole raised to minus 2. Just leave it as it is now. Now take care of those numbers. We have 1000 and 100. 1000 and 100, power 3 and power 2 will make it 10 to the power 5. This is gram. Then you have centimeter per second square. Now what is this gram centimeter per second square? If you compare the dimensions, gram centimeter per second square is nothing but the unit, but everything in CGS. So this entire thing is basically a dian. So that's how I get a Newton is 10 to the power 5 dynes. A Newton is 10 to the power 5 dynes. Okay. Thank you, the warriors. Yes, this is absolutely clear how we convert it. Can we do one more question so that you guys are getting a hang of this? All right. So let's do another question coming up on your screen. Let's say we want to do this, the dimension conversion for work. I want to do the conversion from SI system into CGS system. In SI system, it is basically called as a joule. In CGS, it is basically called as an erg. So we want to know what is the conversion factor. Start off what? What is the first starting statement that you should do whenever you want to do? First, you should know the dimension of that physical quantity before you do anything. Okay. So what is basically the dimension of work? Let's see. Well, work is force multiplied by the displacement. Force I already know is mlt raised to minus 2. So this is m1 l1 t raised to minus 2. Displacement at the end of the day is length. So technically this will become m raised to 1 l raised to 2 t raised to minus 2. So the dimensional formula of work is sorted. Okay, keep that aside. Now let's start with the actual conversion. I want to go from joule to erg. Joule to erg. I might remember the formula or answer, but that's not the point. I want to explain you the method. So I start off with 1 joule. I start off with 1 joule. Okay, let's go. 1 joule is everything in SI. Write it in fundamental terms. So a joule in fundamental terms will have mass, which is going to be 1 kg whole raised to 1. Okay, fine. Then length will be measured in meters. So a meter, but I have to square it because length's dimension has been raised to the power 2. Next, time, it is measured in second, but it will be raised to the power negative 2. Just keep it as it is. Okay, so I have written down the main unit in fundamental units of SI system. Now convert from SI to CGS. Individual quantities. A kg is nothing but 10 to the power 3 grams. Okay, a meter is nothing but 100 centimeter. A second remains a second no matter which unit it is. Okay, just leave it as it is. power 3, this is power 4 and power 3 will become 10 to the power 7. This will become gram centimeter square per second square. Okay, so what is this gram centimeter square per second square? Gram mass, centimeter is length, square, second raised to minus 2. Exactly, this should be the CGS unit of work. So this will be nothing but ergs. So a joule is 10 to the power 7 ergs. Is this absolutely clear? Good evening, Anshul. Perfect. Yes, Bhavesh. Yeah. Sir, you do not know teaching in English. I do not know teaching in English. Yes, you can think whatever you want, but this is an English channel and we'll be sticking only to pure English. Okay. So that's how it is. Okay. There are a lot of Hindi channels, English channels, lot of them are there. And you might have also seen me on Maharashtra channel. Yeah. Where I was teaching in Marathi, Hindi, English. Yeah. So, I can teach in multiple things, but this particular channel will be for all the students who are in English medium, because when you go to IIT or NIT, they do not teach in any local language. They teach in English, number one, no matter which government college you go or private college. Number two, when you go to a job, you cannot talk in any other language. Okay, that's how it is. All right. So we are done with this also. Okay, perfect. Let's take a weird example. Let's take a weird example now. Let's take another weird example. And I tell that there is a Pandu system of unit. In a Pandu unit system, in a Pandu unit system, 1 unit length, 1 unit length is, let's say, 20 meters. 1 unit mass, let's say, is 5 kilograms. And 1 unit of time is, let's say, 10 seconds. Okay. Imagine there is a physical quantity whose dimensions are m raised to 2, l raised to minus 1, t raised to 3. Question is, one Pandu, one Pandu unit, or basically, I would say 1 unit of that physical quantity in Pandu system, in that Pandu system, is how many, okay, units in SI? How many units in SI? That is the question. Let's see if we can solve this. Beautiful question, guys. Okay. So you have some random system, guys. It need not be CGS, FPS, anything. Some random new system. How to do such kind of questions also you should be aware of. So the conversion factors for each fundamental quantity is given. The dimension of the main physical quantity is given. Now you have to convert 1 unit of that physical quantity in this Pandu system into the SI system. Okay. The good part is I already know the dimensions. Usually you should know it, or you can find it if the formula is given. Okay. Now let's write down. Let's write it down. 1 Pandu unit. 1 Pandu unit of that physical quantity. Think in terms of fundamentals. Mass is raised to 2. Okay. So basically it will be unit Pandu mass, unit mass, unit Pandu mass. Okay. Whole raised to the power 2, because mass is raised to 2. So that Pandu system, if you express it in fundamental units, the mass unit will also be raised to power 2. If you check in terms of unit length in that Pandu system, unit length, it could be anything. Okay, it will be raised to -1, and unit time is raised to the power 3. Unit time is basically raised to the power 3. Yeah, I hope this is absolutely clear. Yes, the warriors, we all know each other, man. We might be in different places, but at the end of the day, we know all each other. Yeah. Okay, cool. Next important thing. A unit mass in our Pandu system, a unit mass in our Pandu system is 5 kilograms. So instead of unit mass, let me write down 5 kg. Okay, square. Next, a unit length, a unit length in our Pandu system is 20 meters. So let me write down over here 20 meters raised to minus 1. A unit time is 10 seconds in SI. So let me put 10 seconds, but this is raised to 3. So what will this become? 5 square is 25 kg and this is 20 meter inverse. So 1 by 20 basically meter inverse multiplied by 10 cube, 10 cube second cube. Okay, perfecto. As you can see, 25 and 20 both are divisible by 5. This will go 4 times, this will go 5 times, right? But this is 10 to the power 3, which is basically 1,000. 1,000 divided by 4, 1,000 divided by 4 is 250. Is that right? Now 250 into 5, 250 into 5, that's 125, but 1250 will come because of that extra zero. And remaining things are kg. You have meter inverse, sorry, this was kg square, my bad, kg square, meter inverse, and this is second cube. Now that's it, guys. 1250 is over here as it is. What is this? Kg square meter inverse second cube. Kg square meter inverse second cube is basically the SI unit. So this is nothing but the SI unit of that same physical quantity. So one Pandu unit of that quantity is 1250 SI units. That's how you solve these questions. Yeah, I hope this is absolutely clear. Sir, is second drop good for JEE? I would definitely not advise Anchal. Please, if you can get through some college, go ahead with it. For engineering, second drop is not advisable. Okay, it's a very risky game that you are playing. Okay, unless you are very passionate, very sure you know what mistakes you have done 100%, you have good guidance, you have good mentorship, you have found whatever you need, only then take a second drop. Else, just go ahead, better choose a good MTech or MS or MBA or whatever college. That is what is advisable. Okay, right. Series name, you can call it whatever series, Pandu series, okay, Chandu series, anything you can call. Class 11th, 6 o'clock, class 12th, 8 o'clock. Simple guess. Okay. This time, somehow, surprisingly, we didn't want to name our series anything. Just wanted to do all the classes. Okay. Just go with the flow. All right. Then, now that you are clear, sir, okay. So, first use is to, check check the dimensional consistency and eliminate options and all of that. The second one was conversion of units, okay, and we have seen quite a few examples of that. Now the third application, that is the most interesting formula, which is dimensional analysis for for formulas for formulas dimensional analysis for formulas. Okay, yeah, general candidate, so you should not take a drop. Please don't take a drop, Anchal. Okay, my advice. You will probably like this decision after 10 years or 7 years or something, unless you're very sure with that proper guidance, material, coaching, everything. Okay, fine. So dimensional analysis of formulas, my dear students. So what does this mean? Many times it happens you are struggling in a question and you can not figure out what the final answer will be, but you can guess from the options, because you know the final option should contain this quantity, this power, this should be under the root. Somehow you know. Like for example, if I tell you acceleration somehow will have velocity on the top and time here, it can't have root v by t, or it can't have root of v by t. It will be dimensionally only wrong. So you can make a guess with this particular method, often again used for option elimination and selection. So here what happens is, if if you know the dependencies dependencies of a physical quantity on other quantities and the relation can be expressed in a simple multiplication or division with some powers. Then using dimensional consistency, dimensional consistency, these powers can be obtained. These powers can be obtained. But keep in mind that whatever method I'm going to show you now, this can't be used, can't be used if the actual formula which you want to derive contains, if it contains, what does it contains? Either logarithmic or exponential or some trigonometric, trigonometry kind of thing, etc. Then you cannot use it. In fact, even if there is addition or even subtraction, also you cannot use it. You cannot figure out how many additions and subtractions are there in that relationship. So you cannot use it if there is some trigonometry, exponential, logarithmic kind of expressions in that actual formula. It can be used only for simple things which can be expressed in some simple multiplication and division form with some suitable powers, like kinetic energy is half mv square, momentum is mass into velocity. This is very simple, but still time period of a simple pendulum is 2 pi root L by G. So these things you can use. Okay, this is one thing. Also, you can't find the value of the constant, if any, value of constant of proportionality, if any, proportionality, if any. So if there is any constant of proportionality, then you cannot find it. Is that right? Okay. I'm so glad, but the video very late, just 1 month before the exam. Anchal, no worries. Maybe you can take a partial drop and still give JEE. That will be a better option. And you can prepare for JEE simultaneously. So partial drop will be much better. Yeah. So moving on, moving on, moving on. Yes, Venu, see, what is your doubt? Moving on, let's see how do we exactly use this particular thing. So before we move ahead, just some general information which you should know. If you have sine of something, or basically cos of something, or basically log of something, or e raised to something, or basically tan of something, all these things. So whatever is there in that particular bracket will always be dimensionless. Whatever is there in that bracket, it will always be dimensionless. Keep that in mind. Okay, exponential, logarithmic, all these things, they're all without any dimensions. In fact, e raised to that number is also dimensionless. So again, a very important side note which you should be remembering. Now let's actually put it to a use so that you understand how we exactly use it. Say it is told to you, this is one of the most commonly used examples. Say the time period of oscillation of a pendulum depends on length and acceleration due to gravity. The question is, find the relationship. Find the relationship between them. So, if you take a pendulum like structure like this, and let's say you are holding it over here onto the wall, and you leave it This thing will go back and forth. This will go back and forth. This is the length of the pendulum. Acceleration due to gravity is like this. So for an oscillation, it will oscillate back and forth like this. What is the time period of oscillation? Actually, this is a question from simple harmonic motion, which is a chapter almost nearing the end of 11th syllabus. But that is the beauty of dimensional analysis. Even if you do not know the laws of physics or those principles or other formulas or derivations, you can still get to the final answer as much close as possible using the method of dimensional analysis. That's a very cool way, guys. Observe how. Observe how. Okay, very interesting way. So let's see. First of all, let's see who is dependent on who and all. So as we can see over here, the time period depends on the length and the acceleration due to gravity. It is clearly mentioned. How does it depend? I do not know. Like I mentioned over here, it should be a simple multiplication division with some suitable powers. Only then you can figure out what is that formula. So maybe the time period is some constant, length raised to x and gravitational acceleration raised to y. Okay, length raised to x and gravitational acceleration raised to some y. Okay, fair enough. Now what will we do? By using dimensional consistency, these powers can be obtained. What are those powers? X and y, which I do not know. I can obtain it by dimensional consistency. What is dimensional consistency mean? It means that on the left hand side, whatever dimension is there should be also the dimensions on the right hand side. Should be also the dimensions on the right hand side. But keep in mind, we cannot find the value of the constant of proportionality of any. And actually, I should have mentioned one more thing over here. The constant can't have dimensions. The constant is assumed, the constant is assumed to be again a completely dimensionless quantity. Only when these rules are met, you can use this method. Only when these rules are met, you can use this method. So which means that on the left hand side, we have time. So time is time raised to 1. Constant is basically dimensionless. Length is length only. So length raised to x. Acceleration due to gravity, guys, what is it? Length raised to 1, t raised to minus 2, the whole thing raised to y. Did you understand how this came? Yeah, this is constant's dimension, which is no dimension. This is length's dimension. Acceleration is meters per second square is the unit. So meter means length, per second square means time raised to negative 2. Do not forget those powers, keep it as it is. Okay, now what do we do next? Check this out. So here, if you think about it, length has no power, time has a power of 1. This is dimensionless, forget about it. Length has a total power of x, length raised to x and length raised to y, so x plus y. And time has a power of negative 2y. That is how I get this expression. So using the concept of dimensional consistency, I equated LHS equal to RHS dimension and I solved it assuming constant has no dimensions. That is the assumption always. Okay. Now compare. Now just do the comparison. Now just compare the powers. Compare the powers of similar dimension. Compare the powers of similar dimension. The power of length on one side is 0. On the other side is basically x plus y. Here, the power of time is basically the number 1. Here, it is basically negative 2y. So, if you notice, this will be 1 by minus 2 is equal to y, or basically y is equal to negative half. If you substitute it over here, well, x will be technically negative y. So, therefore, x will be negative of negative half. Therefore, x will be basically positive half. So, we found x and y. My job is half done. I just need to substitute it. Therefore, if you come back from here, time will be constant into length raised to x. X is basically half. G raised to y. That means g raised to negative half. So guys, this is as good as saying this is root of L and this is nothing but 1 by root of g. So this will become constant into root of L by G. This is the answer. So the time period of the pendulum is some constant into root L by G. Can we ever figure out the constant? The answer is no. You can't find the value of constant of proportionality, if any, by this method. I am saying by this method. But if you use actual physics and experiments, only via experiments, this is very, very important. So this constant only via either experiments or via physics derivation, you can find the value of constant. That constant comes out to be 2 pi. Therefore, that formula comes out to be 2 pi root of L by G. But you don't have to find this out. You will see the options. One option will be 5 pi root L into G. Another option will be L into G by something. Another option will be L square by G. Another option will be something root L by G. Something root L by G. Oh, that will be the answer. You don't break your head over the constant. Unless both the options have same root L by G, but the constants are different, that you can't eliminate, because obviously you can't determine the constant, but at least you will narrow down on the options, or you would be eliminating certain options which can't be possible. That is the use of this method. Is this absolutely clear? Yeah. Dimensional analysis, you tell me, warriors, isn't it easy? Burnout while doing exam and during long studies. Others, I'll tell you something. Use the Pomodoro technique where you study for 25 minutes, 5 minutes break, 25 minutes, 5 minutes break. And then after 4 or 5 rounds, take a bigger break and then again start studying. That's one way. Whenever you take a break, never take a distractive break. Okay. Another thing, make a place where you can sit and study, and that should be your routine. And at that place, it's like your temple of worship where you don't do anything else. Like that is only for studies. You don't sit and play games over there, don't sit and gossip over there, nothing. And in that study days, a desk or place, no using phones or other computers and other stuff. Okay, apart from educational purposes. So when you build it into a habit, initially it will be very difficult, but within some 2-3 weeks you will build that habit. Okay, and always develop interest in problem solving. Okay, your problem or question should always interest you. That's how you will get into that habit. Why it is happening like that? Why not like this? What will happen if this happens? So when you think like that, that's when you will be motivated to do many JEE questions. At the end of the day, you have to solve many JEE problems, right? Okay, awesome, perfect. Partial drop until I get a college, but right now I'm studying from. Yeah, Anshul, that is a good suggestion what your parents have given. Please take a partial drop. That will be 100 times better. Yeah, and continue studying from over here. That will be good. Or you can join my Sigma batch. Sigma batch, you will not pinch you anyway because it is very affordable. Yeah. So the link is also there in the description box of every video, like over here. The pro batches are also there, but you also have the Sigma batch right over here for 2026 for droppers and freshers, complete 11th and 12th syllabus. And my goodness, they didn't change the price, huh? It was supposed to go up. My God. Okay. So, oh, I think they have kept it because of our val. Yeah, because of our val. 3,999. Actually, the price will be 5,000 something. So this also I think will go to 6,000. This will go to some 9,000 or something. So this is with Tattva books. This is with quick revision cards. This is without quick revision cards or Tattva books. Usually students are going with this or this. Okay, so you can choose your options of common. It's a pure English match. Taking frequency, speed and density to be fundamental, then figure out the dimensional formula of momentum. Basically, over here, if you notice, what is happening, momentum, the symbol for momentum is basically P, depends on, momentum depends on frequency, velocity and density, which is basically rho. Okay, rho is density, v is speed, f is frequency. All right. So therefore, can I assume p, which is momentum, is some constant into frequency raised to x, velocity raised to y, density raised to z? No harm in that. So now, by using the concept of dimensional consistency, both sides dimensions should be same. So dimension of p will be dimension of c, which is dimensionless, dimension of frequency raised to x, dimension of velocity raised to y, and dimension of density raised to z. Okay, now comes the crazy part. Now P is momentum. Momentum is again mass into velocity. Okay. And C is basically dimensionless. Forget about it. Frequency is 1 by time. So it will be T raised to negative 1 whole raised to X. Velocity is meters per second. So length raised to 1, T raised to minus 1 whole raised to Y. Density is mass per unit volume. So mass raised to 1. Volume is length cube. So L raised to minus 3 because it is divided. So negative power whole raised to Z. Okay, mass into velocity, right? Mass is m raised to 1. Velocity is meters per second. So length by time. Okay. So this will finally become mass is only there over here. M raised to Z, nowhere else. Okay. M raised to Z. Length is there here. So length raised to Y. And this is basically minus 3 times of Z. And time is there everywhere at these two places actually. Time raised to minus X, time raised to minus Y. So that is your final equation which I am getting. Now we have to do the comparison. Okay, without that we cannot go ahead. So everything has been sorted to the simplest possible way. So let's do the comparison. So comparing the powers. Comparing the powers. Let's see what do we get. First thing first. M's power is 1. Here it is Z. M's power is 1. And here it is basically Z. Here it is basically Z. Therefore, Z is just 1. Now, Z is 1. Whose power was Z? Density. So, density's power should be 1. Density's power should be 1. So, automatically D option gets eliminated. Density raised to 1, density raised to 1, density raised to 1. Either A, B or C. Okay. Next, let's look at maybe this guy, length and length over here. Left hand side, it is 1. Left hand side, it is basically the number 1. Right hand side, what is it? Y minus 3Z. Y minus 3Z. But wait a minute, Z value, I just told you, it is basically 1. So Z put it as 1. So Y minus 3. So if it goes on the other side, 1 plus 3 is Y. Therefore, Y is equal to 4. Y is equal to 4. Whose dimension, sorry, power was Y. It was speed. So speed should be raised to 4. It is there only over here. So option A will be correct without even going ahead. Yes, it is correct. You don't even have to check the next one. Speed's power is 4. But if you still want to do it, time is raised to minus 1. So time is raised to minus 1. And over here, it is minus x minus y. So it is minus x minus y. But x value, I don't know, y value is 4. So basically 4 is minus 1. So x therefore will be, take it on the other side, minus 4 plus 1, which is basically minus 3. So x is basically minus 3. So we have solved the question now. Coming back, density will be momentum will be some constant into frequency raised to x. Frequency raised to x. X is basically minus 3. Then next, velocity raised to y. Velocity raised to y. Y means 4. And finally, what is it? Density raised to z. Density raised to z. Z is nothing but 1. So that clearly tells me it is option number A. Got it? How to solve these kind of questions? You will never ever find difficulty after this. Everyone with me? Oh, Tarun, you already have a test on this chapter. Wonderful. Wonderful. Can you guys solve this particular JEE mains question? Okay, as homework now. Okay, can you solve this particular JEE mains question as homework? This is wonderful question. Okay, x as a function of time, a sin t, b cos square t, c t square plus d. This is a previous year question. Please solve this as homework. Yeah, very, very simple. Use the concept, use my hint, which I'm telling you now. Whatever is there inside sign is always dimensionless. Also, sign of any quantity is dimensionless. Use that as a hint. Okay. Answer should be there in the comment section. Next lecture, we will be reading the comments. Next lecture, we'll be reading the comments. So the hint is basically sign of anything. If you measure the dimensions, it will be dimensionless. And whatever is over here is also dimensionless. So that is your hint. It will help you with everything. Okay, perfect. All right. So if you ask me over here, also one more hint I can give you. whenever you have addition and subtraction, the dimensions should be same. The dimensions should be basically same. So all should be of the same dimensions. That is your second hint. All should be of the same dimensions. So x, this and this all should be of the same dimensions. That is your second hint. Ashu now will be able to solve this. Yeah, good evening, cutie pie. Yeah, let's go, guys. Now, let's come to the final part, which is basically significant figures and rounding off and how to handle these kind of things. This will be useful, particularly in the next chapter, next concept, which is errors. But let me tell you what is the significant figures. See, sometimes you might have wondered till what decimal place should I go? Or when I write 5.00, do these zeros even possess any significance in value? Do they have any meaning or not? So that is basically significant figures. Basically, they are nothing but digits of importance. Digits of importance. Digits of importance. And this significant figures, they tell me the accuracy of the measurement. Accuracy of a measurement. The accuracy of a measurement. Like for example's sake, let's say some person measures the length as 5.2 meters. Other person measures the length, no, it is 5.1987 meters. Technically, 5.1987 can be rounded off to 5.2, but this guy is more accurate. So the accuracy is more. Here the number of digits are also more. So this is basically more accurate. This is basically more accurate because it also has more significant figures also, you can say. Is that right, everyone? Perfect. So significant figures are basically like the digits of importance. But how do I decide who is important, who is not important? See, the problem is not with the numbers like 4, 1, 2, 3. The problem always happens because of the decimal or the power of 10 or the zeros. So when to consider 0, when to not consider 0, decimal, powers of 10, all these rules are simply mentioned over here on the next slide. Non-zeros are always significant, like 1, 2, 3, 4 till 9. Every time you have to count them, no option. But all zeros between two non-zeros are also going to be significant. All zeros to the right of a decimal point as well as those to the left of a non-zero digit are never ever significant. All zeros to the right of a decimal point as well as to the left of a non-zero digit are never ever significant. All zeros to the right of a decimal point are significant if they are not followed by a non-zero digit. Okay, all of the zeros after the decimal point to the right of the last non-zero digits are significant. If the zeros to the right of the last non-zero digit are from a measurement, they are all significant. Okay, now whenever you read these things, almost you will feel like falling off. Okay, sir, what the hell? I'm getting fully confused, and these rules are also there in your NCERT and all of that. If you by heart these rules, it's of no use. Better to go by logic. Okay, so let's understand it. Let's understand it. Let's take examples. Simple, guys. Observe. If I have a number like 562 or a number like 56.2 or a number like 5.62. Whenever you have non-zero digits, every time all numbers are significant. So 5, 6 and 2, 5, 6 and 2, 5, 6 and 2. Forget about where the decimal is. They are all going to be significant. So all of them have basically three significant figures. 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 Always. Okay? Fair enough. But the moment 0 comes, things change. Observe how. Imagine You have things like 5.6, or forget about decimal for now, 5602 or 50602 or 50006.2 or 50.602. In every case, all the zeros which are between two significants will automatically become significant. Like 5 non-zeros, this is non-zero. Let's mark all the non-zeros first. Non-zero, 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 non-zero. Anything which is between non-zeros, which is significant, basically, they will automatically become significant. So this zero has to be counted. These two also, these three also, this and this also. So this has 4 significant figures. This has 1, 2, 3, 4, 5 significant figures. This has 1, 2, 3, 4, 5, 6. 6 significant figures. This is 1, 2, 3, 4, 5. 5 significant figures. That's how you solve them. So any zero which is between two significants, they have to be counted. Is that absolutely clear, my dear students? So one by one, if I mention the rules over here, these are all non-zero digits. Non-zeros are basically significant. Non-zeros are basically significant. If you express it visually, then it becomes clear. Over here, this is between between the significance, the zero automatically becomes significant. You have to count such a zero. Now, what happens, sir, if there is a power of 10? Let's say, for example, 2 into 10 to the power 3, 5.6 into 10 to the power 29, 8.08 into 10 to the power minus 7, 708.01 into 10 to the power minus 3. Okay, all these are numbers. What to do in such cases? First of all, whatever is not zero, mark them. Whatever is not zero, mark them. The zeros between them also has to be counted by the previous rule. Wherever you see powers of 10, never count them. Powers of 10, they are never going to be significant. So forget about it. So automatically you will see this has one significant figure, this has two significant figures, this has three significant figures, this has 1, 2, 3, 4, 5, 6, 6 significant figures automatically. Is this absolutely clear? That's how you solve the question. So essentially powers of 10 are not significant. Powers of 10 are not significant. Powers of 10 are not significant. Also, imagine a number like 007, which is Bond's number, or let's say 700, or let's say, 05070, or let's say a number like 0020.08, like this. Now, whenever you see zeros before that non-zero, zeros before that non-zero, zeros before that non-zero, they are definitely not significant. They are not significant. The non-zeros are automatically significant, like this guy, this guy, this guy, this guy, this guy, this guy, sorry, this person. Zeros between them automatically become significant. So now what about the ending ones? There is no decimal point. So when there is no decimal point, this one, here too there is nothing. All of them are again not significant. Ignore them. Yes. Yeah, ignore them. In fact, 700 is the same as writing 7 into 10 to the power 2. So this has exactly one significant figure. And as you can see, this should never be counted. So as you can see over here, this has one significant figure. This has also one significant figure. This has three significant figures, and this has four significant figures. This has four significant figures. Is that right? Yeah. I hope this is absolutely clear. Lalit, there is no crash course for JEE right now because it is too early for a crash course. Crash course starts in November and all. Right now, you have the Sigma batch. The link is there in the description box. Okay, that's a proper full-fledged batch, complete syllabus completion within 1 year. All right. Okay, fine, sir. I understood this. Sir, but what if there are decimals and then zeros? That is very interesting. Imagine a number like 5.0 or 5.30 or a number like 207.0 or a number like 8090.000 or something like this. Now, see, basic things, let's mark this guy, this guy, this guy, this guy, this guy, this guy, this guy. This zero is between two non-zeros. They are all significant. But what about these zeros? If it is after a decimal, significant. After a decimal, significant. After a decimal, significant. After a decimal, significant. So this automatically becomes significant. Okay. So as you can see over here, there are two significant figures. Here you can see there are three significant figures. Here you can see 1, 2, 3, 4, 5. 5 significant figures. Here you can see 1, 2, 3, 4, 5, 6, 7. 7 significant figures. 7 significant figures. So whenever you have a zero after the decimal, automatically it becomes significant, and anything before that automatically will become significant. But sir, what if the number is less than 1? What if it is like 0.002 or 0.0523 or 0.070201 or 0.0005300? What to do in that cases? Basic things like this guy, 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 this, and these zeros are between. They are all significant. But the moment it's a number less than 1, it's 0 point something, then even though the 0 is after a decimal, but because it is, because there is no non-zero number before them, these should not be counted. Never count them. This should not be counted. This should not be counted. This should not be counted. But anything after the decimal, it is there. And after the non-zeros, that should be counted. There should be a non-zero number before that. So this will automatically be counted. Okay. So this guy has one significant figure. This guy has three significant figures. This guy has five significant figures. This guy has four significant figures. Another example, let's say we take 0.0020100 into 10 to the power minus 5. Okay, automatically this one will become significant. This zero is between them, will become significant. These are before the non-zero, not important. These zeros are important, but this is power of 10, which is not important. These zeros are after a non-zero and after the decimal, so count them. After the non-zero and after a decimal should be counted. So 1, 2, 3, 4, 5. So this has 5 significant figures. Is that absolutely clear how to count them? Yeah, perfect. Some people sometimes have, uh, a problem with constants. Say, for example, I have a constant like 2 or a constant like pi or a constant anything. So 2 can be written down as 2.0 or 2.000 or as many zeros as you want. Same thing, pi, I can write it as 3.1 or 3.14 or 3.142, as many decimal places I want to take. Essentially, constants can take up infinite significant figures, as much as needed, but usually you stop at some place because you might not need that much accuracy. So you might take 2, 3, 4, 5 decimal places. After that, you might just stop. Okay. So otherwise, there is no end to it till what level you can take the significant figures of them. Is that right? Everyone? Till this point, absolutely clear? Okay, I know your other class would have started, but let me just complete this particular topic. Now let's talk about rounding of significant figures. That is another important thing for calculation purposes. Well, see this. Say for example, I have the numbers like 7.83. Then I have 7.86. Then I have 7.85. And then I have 8.75. There are two decimals after the two places after the decimal. You can say 83, 86, 85, 75. These are two decimal places. I want to round it off to a single decimal place. Okay, I want to round it off to a single decimal place. What is the logic for that? What is the logic for that? Let me explain to you. It's a very straight off problem, guys. Very easy. So, whenever you want to round off, what you should do is always check the last digit. Always check the last digit which you want to round off. Now, see whether it is more than 5, equal to 5 or less than 5. Like for example, this one is definitely less than 5. This is definitely more than 5. This is definitely equal to 5. This is also definitely equal to 5 only. So if it is less than 5, right? If it is less than 5, then what you need to do is this previous digit which is there, this previous digit will come as it is, over here. So the answer for this particular thing will be 7.8. It makes sense. 7.83, 83 is close to 80, that 0 has to be ignored. So 7.8 will be the answer if the last digit is less than 3. But let's say the last digit is more than 5. Then what you need to do, the previous digit, add an 1 to it, add a 1 to it, and then write it down. Kind of makes sense. 86 is closer to 90. So this will be 7.8 plus 1 is 9. Makes sense. I have rounded it off to a single decimal place. Is this very simple? Yeah. How about when it is equal to 5? Then you need to check whether it is even or not. Well, 8 is nothing but an even number. So 8 will come as it is. 8 will come as it is if it is an even number, because 85 is closer to 80 also and 90 also. So we'll always keep it even only. But the moment it is an odd number, like the number 7 over here, then try to make it even by adding 1 to it. So you are trying to make it even by adding 1 to it. So what will happen? This will become 8.8 because 75 is closer to 70 also, 80 also. 7 will make it odd, 8 will make it even. So always make it even. That's the simple way. Is that right, everyone? Okay. This is amazing, sir. But sir, what if I want to convert some many digits into a single decimal or two decimals? What if it's not always removing one decimal places? What if it is removing 3 or 4 decimal places? For example, like this, 29.570, or let's say 173. 29.150, or let's say 142. 29.150. 29.450. As you can see, there are 3 decimal places and I want to bring it to example 1 decimal place. Example 1 decimal place. So how many places I want to get rid of? 2 places I want to get rid of. Yeah. I have to get rid of 2 decimal places. So 2 decimal places I have to get rid of. I'll just block them in every single example. I want to get rid of 2 decimal places. Okay. Now, when we had to get rid of 1 decimal place, we were comparing it with the number 5. If we want to get rid of 2 decimal places, what will we do? We'll compare it with the number 50. It's obvious. So we'll see whether it is more than 50, equal to, or less than. Obviously, it is more than 50. Here it is less than 50. Here it is exactly equal to 50. This is also equal to 50. Same rules apply, guys, very similar. So what you will do, if it is more than 50, go to the previous digit and what will you do? Add 1 to it. Add 1 to it. Just like over here. If it is more than 5, take the previous digit and round it off to the nearest integer. Yeah, so this will become nothing but 29 point basically 2. Yeah, 1 plus 1 is basically 2. If it is less than 50, then don't do anything. Just bring it down as it is. So this will just become 29.1. Kind of makes sense. 142 is closer to 100. Here, 173 is closer to 200. So that's why we have done that. When the previous digit is an odd number, that odd has to be made even. So in order to make it even, add 1 to it. So this will become 29.2. And over here, because that previous digit is already even, you don't have to do anything. 450 is closer to 400 also, 500 also, but you will write it as 29.4. Is that absolutely clear how to round it off? If there were 3 decimal places which had to be removed, you will compare it with which number? Put it in the chat box quickly. Yeah. If there were 3 decimal places which have to be removed, then what will you do, guys? Yeah, come on, think about it. If there were 3 decimal places or 4 decimal places, what will you do? What will you compare it with? Obviously, you'll compare it with 500 or 5,000 or 50,000, depending on how many decimal places you have to remove. Got it? It's that simple, guys. It's that simple. Perfect. Okay. So this is how you round off digits. Great. So now that you understood how to round off digits, let's say, can you write this down? 509.23010 to 5 decimal, sorry, to 5 significant figures, 0.012059 to, let's say, to let's say 5 decimal places. Okay, this is your second question. Let's see if we can solve this. So these are your 2 questions. Once you get it, most of it you will be able to do now. 5 significant figures. There are a lot of significant figures here. This. All these zeros are countable. Okay. So what do we do now is the question. 5 significant figures means this. So I need to get rid of this guy. Yeah, just get rid of this guy. Now, when there are 3 digits to be removed, what will you do? You will compare it with the number of 500. So 010 is 100% less than the number 500. If it is less than the number 500, what will you do? The previous digit which is there, it will go as it is. Hence, it will be rounded off to 509.23 only. It will come as it is. Is that making sense, everyone? Okay. What about this? 5 decimal places means 1, 2, 3, 4, 5. Oh, so I need to get rid of this number. So 9 will be compared with 5. Okay, single decimal place. So 9 is more than 5. So what shall I do? The previous digit, I should add 1 to it and write it down. So that means it will be 0.01206. 5 plus 1 is 6. That is the answer. Simple. Understood how to round off anything to anything now? It's not a big deal. Yeah. Great. Now, why are we learning rounding off and why are we learning, rules of significant figures, all these things? There is a simple thing. Significant figures, when used in mathematical calculations, you need to follow certain rules. And the rules are as follows. Rules are as follows. For addition, for addition or for subtraction, the final answer should have the least of the decimal places, should have the least of the decimal places. But when you talk about for multiplication and division, the final answer should have the least of significant figures, should have the least of the significant figures. Very, very important. Very, very important. For addition, subtraction, decimal places. For multiplication, division, significant figures. What do I mean by that? Let me demonstrate to you by simple examples. Imagine we have to add the following numbers: 5.20, 7.0000, 3.123. Okay, these are the numbers which I have to add. Another thing I'll take 5.790, or let's say 5.79, minus 2. Let's say 1. Chumma, some random examples I have taken. Now look at these numbers. First, do the normal addition how you would do. Just do the normal addition or subtraction how you would do. So what would it be if you do it? Well, this will be 0. This will be basically 0. This will be basically 3. This will be basically 2. This will be 3. This will be 5 plus 7, which is 12. 12 plus 3, which is 15. So 15 point something. Here also do the normal subtraction. So 9 minus 0 is 9. 7 minus 1 is 8. 5 minus 2 is 3. But this is not the final answer. Why? This is the reason. If you check the numbers over here, this has 2 decimal places. This has 1, 2, 3, 4. This has 1, 2, 3. So out of the 3 numbers, this has the least decimal places. 2 decimals are basically the least. This has 4, this has 3. Check the least of the decimal places whenever you are going to add and subtract. So the final answer should also have 2 decimal places. That means only these two are needed. This and this are not needed. The moment I don't need them, use the method of rounding off. Check these two things. Check these two things. Yep, this is 2-digit number. So compare it with 50. It is definitely less than 50. The moment it is less than 50, go back to the previous digit. It goes as it is. Hence, the final answer to this particular question should be 15.32 directly. Understood? So this is our final answer. This is our final answer. Is this absolutely clear how we did it? Least decimal place should be there in the final answer as that of the numbers being added or subtracted. Okay, perfecto. Awesome. 15.32, not 323, because this had 2 decimal places. Cool? Okay. Okay. Oh, sorry, what did I just do? 7 minus 1, why did I write it as 8? My bad. My head is running somewhere. 7 minus 1 should be 6. Yeah, my bad, guys. So sorry. Something and all I did. Happens at times. Okay. Now coming back to this. Over here, as you can see, this has 2 decimal places. This has 1. So 1 decimal place is basically the least. So the final answer should also have 1 decimal place. So this should technically not be there. So if I want to get rid of the number 9, which is more than the number 5, obviously I should take the previous digit and add 1 to it. I should add 1 to it. So the final answer for this particular thing will be 3.6 plus 1 is 7. So that is your final answer. Understood how to add and subtract taking into the account the decimal places. and why we need to also know rounding off of digits, which I have just taught to you. What are the rules for rounding off? Clear? Everyone? Sarvana, really good. Hi Lalit. Good evening, Virupaksh. Okay. Sir, but what about multiplication and division? Sir, what about multiplication and division? For multiplication and division, you should not check decimal place. You should check significant figures which are least. Okay. Give an example, sir. That will be better. Okay. Let's say 15.00 multiplied by 3.0. Okay. Chumma, I have given something. Okay. And let's see what the answer should be. Versus 0.3 multiplied by let's say 7.000. Okay, then let's say 20.00 divided by 4 point, or let's say 200.0 divided by 4.0. Okay. So some multiplications and divisions which are very simple, just to make you understand how the rules work. Okay, let's see. Start by the basics. First, just like we did over here, first try to add or subtract normally. That means over here also, just try to multiply them or divide them normally. Forget decimals, everything for now. Just try to multiply and divide them normally. 15 into 3, that's basically 45. 15 into 3, that's basically 45. Forget about decimal places. This is 7 into 3, which is 21, but because of the decimal, it will become basically 2.1. Okay, everyone? This is 200 divided by 4, which is technically 50. So just put the number 50. These are the pure values by doing nothing. Okay, we have not taken into account the significant figures. Okay, now let's look at the significant figures. This has 1, 2, 3, 4. This has 1, 2. Oh, this is significant, this is significant, this has 2. So 2 is basically the least significant figure. Here only this is significant. Here this and this 4 are there. So 1 is basically the least significant figure. Here this is significant, this and this. So 2 is basically the least significant figure. Final answer should also contain the least significant figure. So 2, that means 45. So you don't have to do anything. So 45 already has 2 significant figures. So this is the answer. This and this, 2 significant figures. Don't do anything with it. Don't touch it at all. Here, 1 significant figure. So 2.1 has 2 significant figures. You have to get rid of this 1. How to get rid of this one? 2.1, if you approximate it, what will it become, guys? Obviously, it will become 2. Yeah. So now it has been approximated to 1 significant figure. So hence the answer to this particular question is just going to be 2 with 1 significant figure. I just approximated it. I've got rid of that 1 because that number 1 is basically lesser than 5. So the previous digit should come as it is. Going to the last one, it should have 2 significant figures. But remember, 0 is not significant. So how do I write it in terms of 2 significant digits? How do I write it in terms of 2 significant digits? Please understand right now, 5 is significant, 0 is not significant. How do I convert it into 2 significant figures? One option is I can write it as 0.50 into 10 to the power 2. So what happens then? See, this is not significant, this and this are significant, this is also not significant. Yeah, this whole thing is not significant. So now it is having 2 significant figures, or other option is I write it like this, 50 with a point, don't put any zeros. When you put a decimal, automatically this and this becomes important. So both options are correct. So both of them can be the correct answers. Both of them are the correct answers. Is this absolutely clear, my dear students? Everyone? Yeah, don't put 51. No, no, no. You can't round it off to 51. 50 will be 50 only. But you write it in powers of 10 such that it becomes two significant figures. Or put 50 point. 50 point means that 0 before becomes significant. That's the interesting way of doing it. Understood, guys, how to do multiplication, division, etc. Okay, this will be used throughout in the next part of errors also. Okay, so with this, let's see if you guys can write and solve this particular question. The decimal equivalent of 1 by 20 up to 3 significant figures is, come on, 1 by 20, guys. 1 by 20. 1 by 20 is how much? Come on. 1 by 2 is 0.5, 1 by 20 is 0.05. So this is 0.05. But 0.05 is not having three significant figures. We need to add something more to it. 1, 2. So this and this becomes significant. So 0.0500. Yeah. So that is option A, I believe. Yes, perfecto. That is option A. As you can see, these numbers will not be significant. This 0, this 0. Any 0 after a non-zero and decimal will automatically become significant. Okay. Non-zero to has to be significant, and any 0 after a non-zero and the decimal will also be significant. Yeah, option A. All right. All right. Everyone, perfecto. Let's go to the next question on your screen. Here it is. The respective numbers of significant figures for the numbers this, and this are. Come on, direct question, guys. Direct question. Well, 2 is significant, 3 is significant, 2 and 3, and even this 0. So, totally 5. So, 5 significant figures over here. Over here, only one. This, all zeros are not going to be significant. So, useless completely. 2.1 and this power of 10 is not important at all. So, only this 2 and this 1. So, two significant figures here, one significant figure. So, 5, 1 and 2, which is option A again. Very good, Gokul, Miki. Yep, perfecto, amazing. All right. So, that was that particular question. So with this, we have come to the end of this particular class, and I hope you enjoyed it. And if you are interested to check out our pro batches or even our offline batches, they are there in multiple cities across India. And the best part about them is that they have very high-tech facilities, libraries, mentorship, 1:1 counseling, 1:1 personal teacher assistantship. You also get dedicated doubt support within the class, after the class, and our pro batches are exactly like offline, but you get to experience it at the comfort of your home. And all the ranks that I showed you, most of them are online ranks. We started our offline branches just barely 2 years back, but those offline branches have also started producing amazing results. And just this year or next year, many of the batches will start passing out, and you will start seeing huge amount of results, in the coming years. So if you want to be a part of this revolution, do not forget to check out the link which is there in the description box, be it offline or be it online. So let me just show it to you, just in case you have not yet seen. So you can see explore our offline centers, book a visit now. You can see the classroom sizes are also small because we maintain a good teacher-student ratio. You can enter your name details. So many centers are there. Pay a visit to any of these centers and take my name that I came because of Shreyas Sir. All right. And yeah, for those students who don't have a offline center or prefer learning online, you have both these options, 1 year and 2 year pro courses in pure English. So say for example, you go for the 2 year course for 2025, you can also choose English, yeah, physics, chemistry, maths, entire syllabus. You can book a demo for these, okay, using these particular links. Book a demo. So I'm saying don't even join right now. Just book a demo, see how it is. If you like it, okay. If you don't like it, perfectly fine. You just have a demo. Okay. Enter your name and details, and we'll get back in touch with you. Okay. Cool. So smash that like button right away right now and share this video with your friends and solve that homework question and put that answer in the comment section. Bye bye. Take care. Captain Shreyas signing off.